Assalamualaikum warahmatullahi wabarakatuh and a very good evening IB2 Dr. Hani. My name is Anissa binti Sahini with matrix number S34110 and my partner.
My name is Nur Shakira binti Muhammad Rafa. My matrix number is S34178.
So we will be presenting the SCI group presentation regarding to our topic, which are polycarbonate PC and polytetrafluoroethylene PTFE. Let's start our presentation. We will begin with polycarbonate. So polycarbonate materials are referred to as groups of thermoplastic polymers that have a chemical structure containing the carbonate group OC double bond OO. As you can see on this slide, the structure given below, the structure of OC double bond O, and then polycarbonates that are used in engineering must to be strong, tough materials, and some grades are optically transparent. So it is known for its transparency, impact resistance, and versatility. And then polycarbonate can be combined with other polymers to enhance other properties such as thermal stability and biodegradation. And polycarbonate can easily be molded, worked, and thermoformed. We will look to the synthesis of polycarbonate. So polycarbonate or PC is produced by condensation polymerization between bisphenol A and either carbonate chloride or diphenyl carbonate. So there are two types for synthesis of polycarbonate. The first one is interfacial polymerization. So the polymer is usually formed by the reactions of bisphenol A and carbonic chloride phosgene in a basic solution. As you can see on this slide, this one is bisphenol A structure and the second one is the phosgene structure, or also can be called as carbonyl chloride. And then polymerization takes place at the interface between the aqueous containing bisphenol A and organic layer containing phosgene with the help of a catalyst called amine. So the polymerization occurs at the interface where the two layers meet. And then a tertiary amine catalyst is used to facilitate the reactions. So the amine and catalyst accelerates the polymerization by promoting the interaction between the bisphenol A and phosgene. And then the second synthesis is transesterification process. So it involves the condensation polymerizations of bisphenol A and diphenyl carbonate. And this eliminate the use of carbonate chloride phosgene, which is an extremely poisonous gas. So this process is slightly better than the interfacial polymerization process. And this transesterification process use elevated temperatures and vacuum to remove byproducts. So this makes the reactions more efficient by continuously clearing out byproducts, helping to produce a purer polymer. And then polycarbonates have a large number of applications due to their properties. So we will look to the polycarbonates properties first. The first one, polycarbonates has a high strength, making it resistant to impact and fracture. So the polymer can maintain its toughness up to 140 Celsius and down to -20 Celsius. And then the second one, polycarbonate has a high optical clarity, almost as clear as glass. So polycarbonate is an extremely clear plastic that can transmit over 90% light as good as glass. And then it is less than glass, making it easier to handle and install. So polycarbonate is a lightweight. And then Polycarbonate also has a good electrical insulating properties, and these can be useful in electronic products. And then lastly, it is also a good chemical resistant against diluted acids, aliphatic hydrocarbons, and also alcohol. So we will look to the use of polycarbonates in our daily life. The first one, polycarbonate is used to make a safety goggles because of its excellent impact resistance and transparency. The second picture is show the sunroof. So polycarbonate also can be used as our sunroof. And then the third picture shows the dialysis machine. And then the consumer products, consumer goods like water bottles and food containers. And then PC also used in aircraft windows and interior components because of its lightweight and durable nature. And then for the lighting, so LED light diffuser is also used polycarbonate because of its ability to transmit and diffuse light effectively. And then a smartphone cover and also other electronic device components also use polycarbonates, and then helmets due to its impact resistance, and lastly, PC is used for outdoor science advertising materials due to its durability and UV resistance. And then we'll look to the advantages and disadvantages of polycarbonate. So as I mentioned earlier about the advantages of polycarbonate, the first one, it is lightweight. It is also a highly transparent. It can be molded easily even at lower temperature. It is resistant to many acids, alkalis, and solvent, and it is also a good resistant to ultraviolet UV radiations. However, polycarbonate also has disadvantages. The first one, it is slightly expensive compared to other polymers. It is also sensitive to UV degradations. It is also a chemical sensitivity. Why? Because PC can actually be sensitive to certain chemicals, solvent, and cleaning agents. And it is also not suitable for food contact due to the concerns about potential leaching of bisphenol A or BPA. And then lastly, it is susceptibility to scratch. So polycarbonate can stretch more easily than glass without an additional protective coating. So that is all from me. I will pass my presentation to my next partner. Thank you.
Thank you, Anissa. So I will continue the presentation for polytetrafluoroethylene polymer known as PTFE. So this PTFE was discovered in 1938 by Ronnie Plunkett, who is an American chemist for E.I. DuPont Dynamos and Company, now known as DuPont Company. So he accidentally refrigerated this polymer, and from the incident, this polymer is widely used nowadays. So this PTFE is a synthetic fluoropolymer of tetrafluoroethylene, commonly recognized by the brand name Teflon. So I believe when I said Teflon, you will also think about Teflon and non-stick pan, right? Because both of these are related. This TFE is also resistant to chemicals, heat, and non-stick properties. Like I said, non-stick pan, non-stick properties. PTFE is widely used in a variety of applications from cookware, coatings to industrial uses. So the chemical formula of this polymer is C2F4, where this C2F4 is a monomer for this polymer, consisting a long chain of carbon atoms, each bonded to two fluorine atoms by this or by this. Okay. All right, let's continue for the synthesis of polytetrafluoroethylene, PTFE. So this PTFE is generally produced by free radical polymerization of tetrafluoroethylene, the monomer, in a high ratio process. So it consists three processes, where the first process is formation of chlorodifluoromethane, where this chloroform reacts with hydrogen fluoride to produce chlorodifluoromethane. So as we can see in this reaction process, where this chlorodifluoromethane is prepared by the formation of preparation of chloroform and preparation of hydrogen fluoride before it become the formation of chlorodifluoromethane. So this formation of chlorodifluoromethane use SB43, known as antimony trifluoride catalyst, to speed up the reaction. For the second reaction, it's about production of tetrafluoroethylene, where this chlorodifluoromethane from first process is undergo pyrolysis process at the temperature of 600 to 700 degrees Celsius to form tetrafluoroethylene and release hydrogen fluoride. And for the third reaction, this polymerization undergo polymerization of tetrafluoroethylene, where the tetrafluoroethylene monomers are suspended in water and polymerized under high pressure with free radical initiator to create PTFE, as we can see this. So we move on to the properties of polytetrafluoroethylene, where the property is very high working temperature, as PTFE can operate at temperature up around 260 degrees without breaking down, making it ideal for high temperature application. It also has non-stick characteristic because it's extremely low coefficient of friction. It also has very high resistance to chemicals because PTFE is nearly inert, meaning it doesn't react with most chemical, acid, or bases. PTFE also very high electrical resistance. And it also resistant to weather, UV light, and corrosion, and inert, non-toxic, and biocompatible, and also has low friction surface. So, the properties of PTFE explain the uses of PTFE later, where it's applied in food production, where non-stick coatings like non-stick paint used in non-stick cookware such as frying pan and baking trays. Its low friction allows food slide off easily, making cooking and cleaning easier. It's also used in chemical industry, where this polymer is highly resistant to almost all chemicals. So it used to line tanks, pipes, and vessels that handles corrosive chemical like acid and solvents. In chemical industry also, gasket and seals were one of the product and application of PTFE. PTFE gasket and seals are commonly used in valves, pipes, and pump in chemical plants because they can maintain a tight seal without reacting with the substance they contain. Other than that, polytetrafluoroethylene is also used in medical application, where this PTFE's biocompatibility and inertness make it suitable for surgical implants such as graft and heart patch, as it doesn't trigger immune response or degrade in the body. In devices like catheters and surgical tubing, FTFE's smooth non-stick properties reduce friction, making insertion easier and more comfortable. Also, FTFE also applicable in electrical and electronic insulation, where this polymer excellent in electrical insulation and heat resistant, make it ideal for insulating wires and cables in high frequency or high temperature environment. This FTFE also used in electronic components where it's used to insulate and protect sensitive electronic component as it high resistance prevents short circuit and interference, especially in high performance electronics. And last but not least, this FTFE also used in high temperature applications such as oil and gas industry, where pipelining and seal, like in drilling and extraction process, these polymer seals and lining are used in pipes that experience both high temperature and pressure. So this polymer heat resistant and chemical inertness make it ideal for this extreme condition. So we move on to the advantages and non-advantages of this polymer. Disadvantages of this polymer, of course, it has non-stick advantages where has extremely low friction, ideal for non-stick surface, like example we discussed before. It also have a chemical resistance where it's withstand nearly all chemicals. It also has heat resistant. It's stable up to 200 and 260 degree. It's also excellent insulator, which is good for electronic and electric. And it also has waterproof with its low permeability and ideal for sales. But for the advantages, it is a costly polymer where it's expensive to produce because it's take expensive cost to pure the fluorine. And it also has low strength. It has a soap and low tensile strength of this polymer. Besides all of that, it also has hard to bond where it requires special treatment to adhere, and it also decompose at high heat where this polymer also can tolerate heat until 260 degrees Celsius, and it can release toxic fumes when heated above 260 degrees Celsius. And last but not least, it creeps over time where it can deform under constant load. Thank you from us. That's all. Thank you from us.